Okay, I'm going to walk you through number 90, which is an empirical and molecular formula problem, but first has you do some grams to moles conversions, which is kind of fun. So we have a compound, and we have these different percentages up here. We've got carbon, hydrogen, and then the rest is oxygen. So the first thing I would do is figure out how much is oxygen. So if we add 41.39% and 3.47%, and you find out their total and subtract that from 100, you find out the missing percent is oxygen, and it's 55.14%. So that's going to be helpful that we know all the percents. So this one's carbon and this one's hydrogen. Okay, the other thing we need to do before we get set up is to use this sentence right here. If 0.129 moles of malic acid has a mass of 15, what are the empirical and molecular formula? We need to know the molar mass. We are not given the molar mass. They're being a little bit sneaky here. And so you're going to do 0.129 moles, and we know in 1 mole you have the molar mass in grams, but we are not given that, so we're kind of working backwards, and we know the final answer is 15. So you can do the math and you find out that the missing molar mass is 116.28 grams per mole. So that's something we're going to need in a little bit. Okay, so now we're going to do kind of just a regular empirical and molecular formula problem, and we're going to take the percents, and the percents all add up to 100, so you can just go ahead and say that they're grams. So we're going to start with our carbon and go grams to moles, and then you're going to go ahead and do the same for your hydrogen, going grams to moles, and finally your oxygen, grams to moles. And you notice that they are all the same. So you're going to divide by the smallest. You don't even really have to show that. You can if you want, though. Especially if this was your test, you'd want to show it for sure. And you get 1 for all of them. You should always write your empirical formula. So our empirical formula is CHO. Okay, so we know our empirical formula is CHO, so the next step is finding the molar mass of our empirical formula. So add 1 carbon, 1 hydrogen, and 1 oxygen. You get a molar mass of 29.02, and then you have to circle back to the molar mass we found out, and it's 116.28. And we're going to divide that by the molar mass of our empirical formula, and when you do that you get 4. And here's the fun part, we now get to take the empirical formula and multiply it by the molecular formula, and here, the empirical formula by our factor to get our molecular formula. We're all done.